Okay, so you guys have basically now all of these columns filled in, right? So you saw your color, and then you matched it up to a wavelength on your spectrum down here, okay? For your wavelength, so now we're moving to the next column right here, all right? So this is all the post-lab stuff. So I will be writing my work over here, but like I said, it's in your best interest to make sure you're writing it in your journal since you have to show all your work anyway, right? So the first thing that we're going to deal with is this conversion for wavelength in nanometers to wavelength in meters. Now, the reason that we're doing that, we kind of had wrote some notes on this page last week, right? And so we know that c is the speed of light. I'll just write it again. All right, so c was your speed of light, okay, which is 3 times 10 to the 8th power meters per second. And that's the part that is why we can't leave it in nanometers, is because this is in meters. We have to make sure that one's in meters, all right? So this upside down y, this is lambda. This is your wavelength, okay? Little f is going to be frequency, but we'll talk about that again in a second. And then you see our little conversion down here, all right? And just a reminder, wavelength has to be in meters, and frequency we're going to see is going to be in hertz, or per second, all right? So we have to be in meters because we need to use our speed of light, which is in meters per second, not nanometers per second. So as a little recap, oh, by the way, let me pause this real quick. You guys need to go grab calculators. Make sure you have a calculator, one of my calculators, all right? Go grab it. Put it on your desk. Okay, so we now have our calculator, right? So remember what we got to kind of go over beforehand, or if you weren't here that day, this is your first time seeing this, so just make sure you kind of keep practicing the keystrokes with me, all right? So what we're going to do, just clear out your calculator, whatever it's on, okay? What I'd like you to do, because I want to kind of make a point right now, is about how big this number is, right? And so you're going to go ahead and push the blue second, and then DRG. Okay, so go ahead and push second, DRG. Z. Get one. You need one. Go get one. It's on the wall. Okay. All right, so second, DRG, you now have these options. I'd like you to put it over to normal, which is flow. Okay, so go left, put it on to flow. If it was already on flow, cool, you lucked out. All right, and then push enter, and that way we will get to see what the number actually looks like, right? So we're going to go ahead and type in just the speed of light, what it is, okay? So your speed of light is 3 times 10 to the 8th. But instead of typing in times 10, this was the part that we possibly went over, you're going to hit this second, and you're going to hit this little x to the negative 1 button right here. So second, x to the negative 1, you have an E show up on your screen. That stands for times 10 to the, okay? So second, and then this x to the negative 1, you have the E on your screen. We're just going to hit the 8, and then we're going to push enter. So I wanted you guys to get to see it in normal terms. That's a huge number, right? Huge, huge number, okay? So that is how many meters per second. When I say meters, I'm talking about a meter stick. This is this big, right? So meter stick, that many per second. That's how fast light moves. That's why you see lightning before you hear thunder, right? Sound just moves a little bit slower. All right, so anyway, so we have that number. Awesome, cool. Let's go ahead and clear this out. Okay, but what I'm going to have you guys write, if you haven't already, and if you do not have this worksheet, by the way, you can just kind of write it on a piece of paper in your journal. I would just write it on a clean page. So that's your speed of light, 3E8, and it's still meters per second. All right, so because we need to have it in meters, we're going to have to do that conversion between nanometers and meters. So we're going to utilize this conversion, all right? This is not incorrect. It's perfectly fine. It's just I want you guys to be dividing it today, so we're going to use this one, all right? Because with dimensional analysis, That's just a fancy word for saying we're crossing out units. All right. We are going to be taking care of converting nanometers to meters. All right. So in your journal, you might write that. It's going to be part of your lab report, and that way you can go back and look at it later too, right? So converting nanometers to meters. Okay. So with dimensional analysis, what that means, I'm going to write it. You don't have to write this part. You can just watch this part. Nanometers, we would set it up. Let me do it this way. Nanometers times in a line. I would bring nanometers down to the right, and meters would go on top. That way, these are going to cancel out. That's what dimensional analysis means, right? So because of that, we're going to use this little conversion so that way it's a 1 on top. All right, I could have done it the other way and had a 1 on the bottom and multiplied it by this number, but let's go ahead and just go with what we've got. All right, so when we're converting nanometers to meters, basically what that means for you on what you're doing with your lab, you're going to take your wavelength that you wrote down. So mine for barium was 575. I'm going to go ahead and divide it by our nanometer conversion, which is 1 times 10 to the 9, okay? Which means I'm going to type in 1E9. So you're going to take your wavelength and you're going to divide it by 1E9, okay? All right, so when I do that, oh, sorry, back to your calculator real quick. Please, now let's put it back into scientific. So second DRG, you want your answer to show up as scientific, otherwise you'll have a lot of zeros. We don't have a lot of room on our table. So second DRG, put it under Sci, and then go ahead and push enter, and now we're going to be in scientific. Okay, so I'm going to take my wavelength, 575. I'm going to divide it by that 1E9, just like that. So 1E9, okay? I'm going to push enter, and now I have this answer. So the answer that I am getting is 5.75 times 10 to the negative 7 meters, all right? But that's still a lot to write in our data table, so I'm going to be shortening it up to be 5.75 E negative 7. That's going to be what I'm going to be writing, okay? So now in my data table, I can put 5.75 E negative 7, just like that, okay? This way? Okay. All right, so I'm going to give you a second to kind of work on this row, this little column right here, all right? So go ahead and do that. I'm going to pause this video for that, and then I'll show the next one, okay?